Next is question number 86, which says that in a triangle ABC, if a square, b square and c square are in AP, then tan A, tan B, tan C are in. Question from solution of triangle. Let us say how it goes. It is given that 2 into b square is equal to a square plus c square. That is, by sine rule, we can say that 2 times sine square b is equal to sine square a plus sine square c. Here what we are trying to do, we are trying to convert this equation in terms of tan A, tan B, tan C, right? That is, it can be written as 1 minus cos 2b is equal to 1 minus cos 2a upon 2, that can be transferred here, plus 1 minus cos 2c, that is 2 can be cancelled from both sides. So we are left with minus 2 into cos 2b is equal to minus cos 2a minus cos 2c. That is, cos 2c minus cos 2b is equal to cos 2b minus cos 2a. Right? Now, cos a minus cos b can be written as 2 into sine of c plus b into sine of b minus c. Right? And on the right hand side, we will get 2 times sine of b plus a into sine of a minus b. Now, this can be written as sine c and this can be written as sine a. Cancelling 2 on both sides. Now, this can further be written equal to sine of c plus b can be written as sine a into sine of b minus c can be written as sine b cos c minus cos b sin c. Now this is equal to sine of b plus a can be written as sin c into sine of a minus b can be written as sin a cos b minus cos a sin b. Now if I divide the whole equation by sin a sin b sin c, let us say what we get. Cot c minus cot b is equal to cot b minus cot a. That is, cot a plus cot c is equal to 2 times cot b. That is, cot a, cot b, cot c are in AP. Hence, we can say that tan a, tan b, tan c will be in HP. Hence, the correct answer will be option number 3. Next is question number 87, which says that if PA is equal to 1 by 3, probability of B is equal to 1 by 2 and P of C is equal to 1 by 6 and probability of A intersection B, B intersection C, C intersection A is given to be 1 by 6 and probability of A union B union C is equal to 2 by 3. Then the probability that exactly one of ABC occurs is, see, we know that probability of A union B union C will be equal to probability of A plus probability of B plus probability of C minus probability of A intersection B and so on, that is minus 3 by 6 plus probability of A intersection B intersection C. Right? Now, left hand side is given to be equal to 2 by 3. So, from here we can find the value of probability of A intersection B intersection C equal to 1 by 3. These two will get cancelled, minus 1 by 6. So this is equal to 1 by 6. Right? Now, to find the probability that exactly one of ABC occurs, let us say these three are the events A, B and C. So, we have to find the probability that exactly one occurs, that is, we have to find the probability of occurrence of this area, that will be equal to probability of A union B union C minus, from whole we will subtract this area, we will subtract this area and we will subtract this area, right? So it will be minus of probability of A intersection B minus probability of B intersection C minus probability of C intersection A. Now this area have been subtracted 3 times and we wanted to subtract it 1 time. So we will add it 2 times, that is plus 2 times probability of A intersection B intersection C. So this will be equal to 2 by 3 minus 3 by 6, that is 1 by 2, plus 2 times 1 by 6, that is 1 by 3. So this is equal to 1 minus 1 by 2, that is 1 by 2. So the correct answer is option number 3. Next is question number 88, which says that the minimum value of sine of 2x plus pi by 4 plus cos of x minus pi by 8 is. Now, here we can observe that 2x plus pi by 4 can be written as 2 times x minus pi by 8 plus pi by 2. Right? This will give us 2x minus pi by 4 plus pi by 2, that is 2x plus pi by 4, plus cos of x minus pi by 8, that is, this can be written as cos of 2 times x minus pi by 8 plus cos of x minus pi by 8. Let us say this angle is alpha. So this is equal to cos 2 alpha plus cos alpha. Now this can be written as 2 cos square alpha plus cos alpha minus 1. Taking 2 common, it is cos square alpha plus cos alpha by 2 minus 1. Making perfect square, it can be written as cos alpha plus 1 by 4 whole square minus 1 by 16 minus 1. So this is equal to 2 times cos alpha plus 1 by 4 whole square minus 1 by 8 minus 1, that is minus 9 by 8. Now minimum value of this will be minus 9 by 8, that is at cos alpha equal to minus 1 by 4. Right? So the correct answer will be option number 1. Next is question number 89, which says that if 1 minus p by 2, 2 minus 3p by 6 and 1 plus 6p by 6 are the probabilities of 3 mutually exclusive and exhaustive events, then p cannot be equal to. This is something like this. Let us say these are the 3 probabilities, right? These are the 3 probabilities. So we know that adding these 3 probabilities will give us 1. So let us apply that condition. This is 1 minus p by 2 plus 2 minus 3p by 6 plus 1 plus 6p upon 6 is equal to 1. Now this will give us, multiplying by 6 on both sides, we will get 3 minus 3p plus 3 plus 3p equal to 6. Now from here we are getting right hand side equal to left hand side. So this is true for all the values of p. Next we have to apply that 1 minus p by 2 will go from 0 to 1. Also 2 minus 3p by 6 will go from 0 to 1 because the probability is always lying between 0 to 1. Also 1 plus 6p upon 6 will go from 0 to 1. Now this will give us 0 is less than equal to 1 minus p is less than equal to 2. Further it will give us minus 1 is less than equal to minus p is less than equal to 1. That is p will belong from minus 1 to 1. And from here we will get 0 is less than equal to 2 minus 3p less than equal to 6. Further it will give us minus 2 is less than equal to minus 3p is less than equal to 4. Further it will give us p going from minus 4 by 3 to 2 by 3. Right? And from here we will get 1 plus 6p will go from 0 to 6. That is minus 1 is less than equal to 6p is less than equal to 5. That is p will go from minus 1 by 6 to 5 by 6. That is the 3 conditions that we have is these ones. So taking intersection of these 3, we will find that p will belong from minus 1 by 6 to 2 by 3. Now 5 by 6 is not lying in this interval, so we can say that p cannot be equal to 5 by 6. So the correct answer is option number 4. Now the last question of this paper is question number 90, which says that if sin square x minus sin x minus y square plus y is equal to 0, then the number of possible integral values of y is r. We are given that sin square x minus sin x is equal to y square minus y. Making perfect square on left hand side, we will get sin x minus half whole square minus 1 by 4 is equal to y square minus y. Now sin x goes from minus 1 to 1. So sin x minus half will go from minus 3 by 2 to 1 by 2. That is sin x minus half whole square will go from 0 up till 9 by 4. That is sin x minus half whole square minus 1 by 4 will go from minus 1 by 4 up till 2. That is y square minus y will go from minus 1 by 4 to 2. Now this can be written as y minus half whole square minus 1 by 4, right? That is y minus half whole square will go from 0 up till 2 plus 1 by 4, that is 9 by 4. Now we have to find the number of possible integral values of y. So from here we can see that y can either be equal to minus 1, it can be equal to 0, it can be equal to 1, it can be equal to 2. So these 4 are the only possible values of y from here. Hence we can say that number of possible integral values of y is 4. That is correct answer is option number 3. So this was the AIATS that was held on 17th Feb 2019. Thank you for watching.